Hey everyone, welcome to uh, interoperable Fugue SQL, interoperable SQL and Python for interactive workloads. My name is Kevin. I am one of the Fugue maintainers. I hope you can see my screen. I'm happy to be here at Trino Fest. So with that, let's get started. Um, so just a brief introduction to what Fugue does. Uh, SQL aside, this is just on the Python side, is what we have a very thin wrapper around code that you develop on and iterate locally. So pandas, polars, or arrow, and we bring that to the distributed, like we execute that on a cluster distributedly for you using frameworks like Spark, Dask, Array. So just by providing a very thin wrapper around your code, we can bring your code over to the to large scale execution. And just to provide a full picture of Fugue, we have the Fugue Python API and we have the Fugue SQL API. And um, on the Python side, we support these frameworks. I won't go into it too much because we're focused on SQL today. And on the Fugue SQL side, we have BigQuery, Trino, Snowflake is in progress, and we also have DuckDB. And there's two important pieces here that we're going to talk about. Number one is with DuckDB. So DuckDB is a local SQL engine that can run on top of CSVs or Parquets. So one of the common things we do is we prototype our SQL queries on DuckDB. And when we're ready to execute it on full scale, we bring it to Google BigQuery or Trino or Spark SQL. And the second thing that's also important here is that uh, a lot of times SQL can be limited in terms of the operations that you can do. So what we focus on is connecting these tools together so that you can leverage the best of both ecosystems. So for example, can you pre-aggregate with a query on Trino or BigQuery, and then you do your post-processing or your machine learning in Spark or Pandas. And we're also going to show an example of that today. So let's talk about SQL development first. And what are the problems with SQL development? So if we take a look at a SQL query, which can be 100 or 200 lines of code, in this particular query we have four tables that we're working with. So A, B, and C feed into D, and it's very common to find SQL queries like this. So our question is, how do we iterate on such queries effectively? And let's take a look at why it's hard. Number one, it's hard to break up a gigantic SQL query into individual steps and allow users to iterate on each individual step. And then number two, it's hard to find out where the slowdown is when the queries are so big because it's very hard to debug these long SQL queries. And then number three, how do we apply software engineering best practices like unit testing on SQL? So can we actually include it as part of our test suite? And then it becomes even harder when you're testing on a live database, for example, right? So that's one of the things that Fugue can help with. So, just a quick. This is just a quick. We'll go over the slides quickly, but then we'll go over it in more detail as I show code examples. But we'll just show what the Fugue SQL syntax looks like. So first of all, you'll notice that this is Fugue SQL Spark, but this will also work on local with DuckDB or with Trino. We have a slightly different SQL syntax. So the first thing that you'll notice is that there is no with statement. So we take out CTEs, we remove a lot of boilerplate code. And then the second thing that you'll notice is at the bottom over here, we have sample 1%. So let's say you have a large table that you're working with. One of the things you can do is just sample down 1% and then proceed to iterate locally. So we yield a local data frame. And then now we can use a local engine like DuckDB, or we also have a SQL on top of Pandas. And now you can use these local engines to iterate before you proceed to the next part of your query. We also have a yield to file, and this is similar. The yield data frame just brings it to a local data frame, and then yield file will just save this into a local file on your local system, so that if you need to use this data or you're iterating a lot on this data, you can just load it from the file instead, rather than having to requery and process everything with Trino or with Spark again or BigQuery, and then pull everything down again. So here, if your previous step is already good, then you can just yield the file and then use it later. And I'll show that more in a bit. Um, so here we're already using a local engine, so we can just pull that from a local cache and then just proceed to use it. And then once you're done, something that FugueSQL allows is having multiple select statements. So here we have a this variable ss, and then that is the output of that will store the result of this select statement. WS will store the result of this select statement, and same thing. And then we can put them all together in result, where you can use all of these previous tables, and then we can yield that final result, meaning we put that in memory so you can consume it with Python or pandas later on. So FugueSQL is a bit different. And what this lets us do is we can now iterate on SS, WS, and CS individually. So here we bring the iteration process on a per table basis, and then now we can test everything together at the end of it once we're done iterating on each local step. And then the last part on testing. So let's say we have this query that we already have. How do we put that as part of our test suite? We have, and also for productionizing, we have this function called FSQL. So FSQL can take in a query and an input table, and the input table can even be a pandas data frame, and then we can run it on a local engine with DuckDB. So now we can include the queries as part of our test suite, and we can unit test using local engines before we bring it over to Trino or to BigQuery. So with that, I'll just show what this looks like in code. I'm going to make this bigger. So the first thing that we're going to do is just call this setup function. And this just provides, it registers this this FSQL cell magic. So here I'm going to be using Trino. So this will work with BigQuery also, and we're working on Snowflake. It will be very similar. And then our SQL interface already works on Spark and Bask. So here we have, we're creating the Trino client, and I'm using Starburst. So you're gonna see this, the host and the catalog over here. One of the requirements for Fugue SQL is that sometimes we'll persist intermediate tables. So what will happen is, like, let's say you do a pre-aggregation and then you want to persist that table. We have to write it in a temp table before it can get consumed by downstream processes. So over here in my Starburst Galaxy, you're gonna notice that, I'll make this a bit bigger. You'll notice that in this Fugue2 cluster, I'm using BigQuery to query my data from, and I'm using cloud storage as to persist those temporary tables. So this is just because BigQuery is read-only as a catalog. So there's just a few things that you need to tweak if you are, depending on what backends you're using with Trino. So if you have any questions, please just feel free to reach out and we can help you get set up, because it can take, there's some variations in how you have to configure things. So the first thing that we're going to do is we have this table in BigQuery, and this is Python code now, and I'm just storing these as variables. And now our initial query. So I'm using this FSQL Trino, this FugueSQL Trino, will use this client that I created earlier, and we'll run this query. So, and then this part is just Jinja templating, where we use this variable. So with that, we can run this, and the print statement will show us the first 10 rows of the result. So I think the first couple queries may take some time because there's a warm up with the cluster. But so here we have the results, and this is here in this query, I just have name, gender, and the count for how many. This is a data set of names. So here we just did a simple group by. And again, print is the one that allows us to show the results. Now what we're going to do next is, and this is where we start to see some specific Fugue SQL syntax. So with Fugue SQL, all standard SQL operations will work. We only added syntax to it. So if you wanted to use CTEs as well, that will work in Fugue SQL. We just tried to simplify the syntax. and add some operations. So here in the first part, I'm doing that same query, but I'm assigning the result to df. And then you're going to see this operation, which is FugueSQL. So a very common operation in SQL is I want to sort my data frame by a certain column and then take, let's say, the top 5 rows, the whole rows. And this normally requires like a self join. It takes some additional code to perform. So, but it's very common. So on the Fugue side, we have this take keyword. So here we can say take, and n is 3. So take 3 rows from this previous data frame, and then pre-partition by gender, pre-sort by count. So we're getting, for each gender, we're getting the top 3 count, and then we yield the data frame. And again, like I mentioned before, what yield does is it brings that data frame into memory and then lets us use it for downstream operations. So this works already. This query ran. And now what you're going to see is that this names uh, table, if I is now a Python object, and if I print it, you're gonna see that it's a Trino data frame uh, over here. Trino, and just some background. Actually, uh, Fugue. If you went to the IBIS talk yesterday, Fugue actually uses a lot of IBIS under the hood. But one of the main differences between Fugue and IBIS is that for Fugue, if you change this engine, whether it's Trino, whether it's BigQuery, or even if you say Spark or DuckDB, something that we spend a lot of time on is guaranteeing consistency. And what this lets you do is change engine and have consistent results. Like for example, if you sort uh, a, a, a column of a table and there's nulls in that column, are nulls first, are nulls last, are nulls the smallest value or biggest value? These are things that can change a lot depending on the backend that you're using. So if you do a group by, are the nulls retained, are the nulls left out? So on the Fugue side, we have a unified test suite, and we make sure that each of our backends has consistency. So we add some additional code in order to handle those inconsistencies. And that's one of the key features of Fugue. And what this lets you do is that you know that if you prototype something on your local system and you bring it to execution on the bigger data set on Trino or BigQuery, you know that it will perform exactly the same. So this names is a Trino data frame, but if you wanted to iterate it on, iterate more on it in pandas, for example, like you're a data scientist and you just wanted to pre-aggregate your data and bring it down to the local setting with pandas, what you can just do is convert this to um, to a pandas data frame using the Fugue API. And this will give us the same data frame except in pandas. Now, the next thing I'm going to show is this these built-in extensions with FugueSQL. So something like I mentioned previously, something that we're really thinking about is how can we leverage the best of both, like the SQL ecosystem and the Python ecosystem. So here I'm going to do a select statement. Again, my table is parameterized. This names over here is actually this the result of this previous query, right? So this names will be picked up from there. And we're just getting, and this one holds the top 3 names. So all that we're saying is that get the rows where the name is within the top 3 names. And what you're gonna see, the important part here is this output using seaborn line plot. So if you're not familiar with seaborn, seaborn is a plotting library in Python. And what we're gonna do is we're gonna get the output of that SQL query, and then we'll use seaborn on top of it to visualize it. So I'll run this real quick, and you'll see the result. I mean, I hope this doesn't take too long, but then if it does, then we can move. Oh, here. Okay. So you're gonna see that we got the top 3 male names and the top 3 female names, and we plotted the count of them over time. And I'll make my screen a bit smaller. So we used the we used the here. What happens is this SQL part will run on Trino, or will run on BigQuery or on the warehouse. And then the moment that you need to invoke a Python function on it, Fugue will bring it out into memory and then execute that Python function on that data that was pulled from the warehouse. So here we use the seaborn line plot, and this is a built-in thing that Fugue has. So as long as you have seaborn installed, you can use this. And we also have like pandas plotting, matplotlib, ipyvzoo. But you can also very much like just make your own Python extension. And we also have additional keywords. Like for example, we have another keyword here. Like you could say transform. I'll just bring this here. We have another keyword called transform. So you can say transform using and then a Python function. And then this also has like pre-partition and pre-sort. But the important part is that you can define your own custom Python transformation. And we'll see an example of that later, actually. And then you can just invoke it on top of this. So at that point, again, Trino will pass that data, and then you'll apply that Python function, and then you'll get a pandas data frame back. So this is for data scientists who want to iterate a lot on their maybe they're trying to build like pre-process the data to bring it to a machine learning step. This lets data scientists iterate through these SQL queries and these transformations. And then if you wanted to productionize this, we have this Fugue SQL function. So all you have to do is import the Fugue API and then invoke this function. And all of this is what I just showed you earlier, right? So that is this query, this query over here with the names, and then the one afterwards where we have the extension. And all that I'm doing is I am removing the yield statements. So instead of caching the intermediate steps, I remove the yield statements. And now what's going to happen is it will just treat this all as, it will submit this all as one query to Trino. And here I'm just saying engine is Trino, and then these are my parameters. So if I wanted to test this locally on DuckDB also, I can just change this to a file path, and then I can say DuckDB. So I'm gonna run this, and you're gonna see the same results. Well, and then we don't really need to wait for this. And then another thing that's important is sampling for local iteration. So a while ago during the slides, I showed this. A very common operation is in order to, if your data size is really big, in order to accelerate iterations, what you're gonna see is uh, you'll sample down the data set to begin with, and then you'll iterate on the local engines. And then once your query is ready to be brought back into Trino, then you will just change the engine back to Trino. So this ran. It just didn't. The rest here is a data frame. I can show that real quick. Oh, okay, it didn't materialize. But yeah, the query here is stored under this variable, and then you can bring that into Python if you wanted to. And now here, so with sampling for local iteration, I'm gonna run this, and I'm just gonna get 1% of my data, bring that into a local data frame called test. And once that's there, you're gonna see that I can now use this DuckDB engine, and it's much faster. This DuckDB engine will be significantly faster because now this data frame is stored in memory. So I can iterate further with this DuckDB query. Or if you wanted to continue on with pandas, you just materialize it as, you just convert test to a pandas data frame, and then you perform your following pandas operations on it. The last thing I'll show over here is combining like the data warehouses with the distributed computing engines like Spark, Dask, and Ray. So a while ago, I mentioned that FugueSQL also has a transform keyword. So the FugueSQL API and the Fugue Python API have one-to-one parity. So everything that you can do in the FugueSQL API and the Fugue Python API, you can mix and match between the two. So here what we're seeing is that we're going to define a Python function, that just gets the median. So if you wanted to get this in SQL, it's a lot more code. And this is going to be a group by median operation. So we want to get the median per state. So what we're going to do is define this Python function. And then you're going to notice that I'll run this already. What you're going to see is that we're using the Trino backend and we're passing in a query. So we're going to get these two columns from this table that we've been using Trino. And then this is and then we're going to apply the median function on it for each state using the Dask engine. So again, with the engines, you can combine it with Spark, Dask, or Ray. Here, we're just using a local Dask cluster to parallelize it. So what's going to happen is this Trino table, the query will run, and then it will get pushed to a temp table, which is why I mentioned earlier that I have Google Cloud Storage here. So there's now this Fugue temp schema, and when I run that cell in my Jupyter notebook, you're going to see that a new table will be persisted here. And this table contains the results of that query. And then what's going to happen is now Dask will, or Spark Dask array will distributedly load that query into all your workers over a cluster. And then they'll apply that Python function on each partition of that data that was loaded in. And then the results will be stored in a this one, the output will be a Dask data frame because our engine was Dask. So you can do stuff like, for example, you can do like if you have like, let's say a table in Snowflake or BigQuery, and there's multiple regions in that table, something you can do is create a function to train like a machine learning model for one partition or one region of your data. And then now you can use Fugue to run that machine learning model training on each of your regions of data, distributedly using Spark Dask array. So here we got the median per the median per state. So the key takeaway here is that FugueSQL it tries to extend the traditional SQL syntax to go beyond the limitations of traditional SQL. So traditional SQL tends to be hard to iterate. It tends to be hard to test. And also it's limited in the operations it can do. So on the Fugue side, we want to break these limitations by number one, allowing you to invoke Python functions. Number two, we provide a bridge between the local setting and your warehouse setting, so you can test more on the local setting before bringing your queries to the distributed or to the warehouse side. And then number three, we also add additional keywords such as these take, transform, output, which you saw over here. And what this lets us do, And what these let us do is use SQL as the main driver. So often you find that SQL is a second-class citizen in data science code, where you have Python code, and then you have a line of SQL, and then you have Python code again. What we want to do is we want to elevate SQL to be a first-class citizen. So instead of having Python invoking SQL, we have it the other way around, where now you have your SQL script invoking Python code. So everything I showed today is in the Fugue documentation. We have this Fugue with Trino page, which I also linked in the slides. So if you want to test out the Fugue Trino integration, please feel free to just join our Slack. Our Slack is also present in the GitHub repo. Again, Trino will require a bit of setup or configuration depending on what backends you're using. So definitely chat with us so we can help you figure out the best way to configure your environment. And with that, thanks a lot for joining me today. That's it I have. I'll just leave two links here. Number one is the Fugue project, the Fugue project repo. Just a slight caveat, this is our main repo, but then the Trino and BigQuery integration are in a different project called Fugue-warehouses, which are also linked in the README here. And then the second link that I'm leaving here is our Fugue Trino integration documentation. And with that, thanks so much for coming, and I'm happy to answer any questions in the chat.
Evan, that was great. Thank you so much. It looks like a very powerful combination. I also loved how you pulled all the different tools together: Jupyter Notebook, Starburst Galaxy, Python, SQL. You're like everywhere. That's great.
Thank you. Yeah, thank you. We definitely want to focus on interoperability between the tooling.
Yeah, I think I'm going to have to upskill a little bit on the Python ecosystem, on all the things that are now possible with IBIS and Fugue. And it's really amazing how you can combine these different workflows and analysis tools and make it suit for different people.
Yeah, definitely. We want to bridge, because like a lot of times what you're going to find is that, let's say there's an organization, and let's say Trino is their the main way they interact with their data. A lot of times, like, data scientists can be underserved by that, just because there's a lot of like, they have to run a Trino query, export that data out, and then work on that exported data, right? So what we want to do is we want to accelerate that. If the data changes underneath, they just requery it again. We want to really bridge the tooling, so that data scientists don't need to go through this like process of querying, exporting, and then running their machine workloads on it. We want to unify that into one place.
Yeah, and I think it's exciting on our end in the Trino community, because it means more people getting their hands on Trino than ever before. And for y'all, it means more people using Fugue for different things. You can plug it into whatever you want. So I think it's an exciting combination of tooling. It's the kind of thing that a lot of people could probably take advantage of. If you've been in one space and you've wanted to use the other for a while, this is what bridges that gap. So.
And where is it running already? Like, I'm sure this is not just you hacking around on it. Like, Fugue must be used somewhere already. Can you maybe share some use cases that are out there already?
Oh, Lyft uses Fugue and Trino together for sure. Yes, they already do. And in Fugue, in Lyft, they have and I see Han is on the chat here. He can also answer if he's around. So Han is the main author of Fugue, and he's here in the chat with us. But then on the Lyft side, I can actually drop an article as well about this. Because what happens is they have, I think this one will mention how they use it inside their environment. They can use Spark or they can use Trino, and they just choose which one to use depending on what type of query or what type of workload they're running.
Yeah, that's very cool. So yeah, Kevin just chimed in. Thanks for posting that link for the community there, and Han is on. So that also obviously helps people that have different skill bases, right? Like nowadays, I think it's more common to learn Python in high school and university than it is with SQL. So
that's true. But we find that it's the data practitioners that we talk to are very polarized. In terms of like, hey, I don't want to touch SQL, or I don't really want to touch Python. And we on the Fugue project, we personally advocate that, like, using the best of each tool, right? So, and we think that it's strongest when you mix them together, because SQL itself is beautiful in a sense that it's already a unified language, right? Compared to like all the Python frameworks that have their own implementation. SQL is like readily understandable by a lot of data practitioners, right? Because it has that consistency.
Yeah, it's definitely a different language paradigm, right? Like if you're thinking very object oriented or like procedurally, that's not what SQL is all about. It's very different. So it's definitely good to combine it with another programming language. So that's cool.